We're going to be looking at index laws, but in order to look at index laws, we're going to first of all look at algebraic terms. Now, a term is normally made up of two parts. We've got our number part and our variable part. So, the number part is pretty simple. It could be any number. It could be a number like 5 or 3 or 1.4 or anything like this. And this number part is called a coefficient. So the coefficient is any number part of the algebraic term. We've also got the variable part, and this variable part could be a combination of one or several variables raised to a power. For example, the variable part could be x squared, that's x raised to the power of 2, x squared. It could be y cubed. It could even be x squared, y cubed together like that. So we've got two variables, both raised to a power. It could just be a. Okay, and that's a key thing that I'm actually going to let you know now. So pause what we're learning there. Any number, a, 6, 3, to the power of 1 is just itself, 6. We know that 6 squared is 6 times 6. 6 cubed would be 6 times 6 times 6. 6 to the 4 is 6 times 6 times 6 times 6. Each time it's getting 6 times bigger. So to get from 6 to the 4 to 6 cubed, we divide by 6. Here, you divide by 6. 6 to the 1 would just be 6, and 6 to the 0, so from dividing by 6 and dividing by 6 again, 6 divided by 6 is 1. In fact, anything to the power of 0 is always 1. Okay? 1,000 to the power of 0 is 1. All right, let's take that aside. So, to recap, we've got our number part and our variable part of any algebraic term. Now, for example, let's say I had 5x. This means 5 multiplied by x. We've got our number part, our coefficient, and our variable part. Now, although it's true that 5 times x is the same as x times 5, we don't actually write x5. In algebra, the number goes first. The coefficient goes before the letter, before the variable. So make sure you're writing them like this. Okay. So we're now actually going to use what we've learnt to look at indices. Indices, which is another word for the powers involved. So let's look at these index laws. Let's say you're asked to do x cubed multiplied by x squared. Well, x cubed is x times x times x, and x squared is x times x, and you are multiplying these together. And if I look at that, that is the same as x to the power of 5. How could I have got the 5 straight away from looking at this? I could have just added them, so that'd be x to the power of 3 plus 2, which is x to the power of 5. All right, let's try it with another one. Y times y to the power of 6. Well, y is just y to the power of 1, we've already said that, but it's y, and then y to the power of 6 is y times y times y times y times y times y. If I multiply these two together, I've got y to the power of 7, and I could have got that from here by remembering this is to the power of 1, and that's y to the power of 1 plus 6, which is y to the power of 7. In fact, this will work every time. So if I have x to the power of any number multiplied by x to the power of any number, that's the same as x to the power of the sum of these numbers added together. I'm going to do one more example for you. And it's going to be slightly different this time because we're going to have some coefficients in there as well. Let's say you are asked to do 5x cubed multiplied by 7x to the power of 8. Now, you've got lots of things going on here. First of all, remember that you're multiplying here and you're multiplying here. The multiplication is implied. So you've got your coefficient, your number parts, and your variable parts. Now, in algebra, when using index laws, we do the numbers first. The numbers will end up first. We're going to do them first. So any coefficients, I've got the coefficient 5, I'm multiplying it by the coefficient 7. 5 multiplied by 7 is 35. Okay, I've now got my algebra parts, my variable parts. I've got x cubed multiplied by x to the power of 8. Well, I can either do that out the slow way, x times x times x, and then x times, and I'll keep going until I've got 8 of them. Or I can remember this rule here, and I can just add these, so it'll be x to the power of 11. Don't forget to put the x there, otherwise it's not correct. Now here I've got my number part and my variable part, and this is an algebraic term. And in fact, I am going to do one last example for the really high-level challenging yourself questions. As you can see here, I've got loads going on. I've got numbers, I've got x's, I've got y's. So I'm just going to think a few things. First of all, I remember coefficients go first. Coefficients are going to go first. Well, what coefficients do I have? Of this term, my coefficient is 3. I'm multiplying it by the coefficient of this term, which is 11. 3 multiplied by 11, 33. Now I've got x's and y's, so let's do the x's first. I've got x squared multiplied by x to the power of 8. So again, I could write out x times x, and I could write out x times x 8 times, or I could remember the rule that it's x to the power of the sum, the adding together of these indices. Now I haven't quite finished yet, because I've also got my y terms here. I've got y to the power of 5 and just y. So I can write out y times y 5 times and then multiply it by y, or I can think about my powers. I've got 5 here, but I don't have a power here, which means what number should be there? Y is the same as y to the power of 1. So that's a 1. So I've got y to the power of 6. And this is your final answer here. 33, x to the power of 10, y to the power of 6.